It has similar post routines to what your machine has. But it goes through this initialization phase where it does self-checks, it does the spindle spin up, make sure that the heads unmount, and then it goes into reading what's called the SA area. So this red line I've got on the outside, it can be in a couple of places on the drive. Usually it's in the center, the outside edge, or it could be in the middle. So somewhere on the platter, you will normally have the system area. And so that SA area is very, very important because that's what we're trying to find out if the drive got through any portion of that so that we can say in our mind, well, I know where it was and what has happened. So let's talk about that for a second and what's in the system area. So the system area has S.M.A.R.T data in it. So there's this extra little area that before you ever get to your user data, that these S.M.A.R.T logs and this other content from the system area has to load. So it does not matter if you can't read your user data. If you can't read the S.M.A.R.T data, in most cases, you're not going to get to your user data. Something else has happened, an exception has happened, or it has failed. So we have S.M.A.R.T data, we have things like system logs, your serial number, and your model number. Now, this has changed since like 2002. Prior to 2002, you may actually get a model number or a serial number. You'll usually lose like a size, like it won't give you the geometry of the disk, or it'll say something stupid like 2 terabyte for a 40 gig drive or something. So it's important to follow whether or not your serial number and your model numbers have been interpreted correctly, even at a lower level when you're talking to a tool like MHDD. Because you can use MHDD to look at this damaged drive, and you can tell it, you can say Shift F2, and it will tell you what's my model number, my serial number, my drive, even if your BIOS never showed it. It's still possible to see it. So it's important, though, to know that the S.M.A.R.T data is coming from that. So is things like your bad block list, your serial numbers, and your model numbers. So this is why S.M.A.R.T sucks. S.M.A.R.T thinks, it's supposed to be about predicting whether or not your drive is going to fail. But these numbers are just these arbitrary numbers that somebody made up and stuck into these for threshold numbers. And a lot of people don't even know what they mean or understand what they are. And when your drive is starting up and your BIOS sees it, the whole point is to boot very fast. To boot as fast as possible. So a lot of the extended checks are all turned off, so that you have a 5-second boot time or a 7-second boot time or whatever it is to make Windows boot faster or Linux boot faster or whatever. So it does a very generic check. It's not doing very comprehensive work at all. And in some cases it's completely disabled. It doesn't even do a check at all. It doesn't even bother to tell you that this isn't working. The other thing is too, S.M.A.R.T tables can actually cause the drive to fail. In other words, you don't need S.M.A.R.T. It actually provides you nothing that you need to make the drive work, but it can stop your drive from working. The reason I say this is that the way that the drive works is it goes through, it loads the system area, it loads the content from these tables, and if the tables are corrupt, there's very, very little error checking that it does to say, hey, look, I didn't mean for this buffer overflow or something else to happen. It causes an exception failure, and the drive's code actually sees an exception and just farts all over itself. It doesn't do anything else at all. It just stops and basically freezes in time with a firmware failure because of the S.M.A.R.T table. So data recovery people, the first thing they do when they hook it up to a piece of equipment is clear the S.M.A.R.T table because we don't need it. It's worthless to us. It tells us nothing except that either I read it or I didn't read it. Nothing else. And this is what it looks like. It looks like, just a bunch of arbitrary numbers. This is a tool called G-Smart Control. Some of you may have seen it before. You can go and find out what some of the things are that mean something. But again, warranty applies in a lot of cases. If your drive says I'm failing, you'll send it back to the manufacturer and say, your drive said it was failing, please replace me. Well, they don't want you sending it back. It's under warranty. It's going to cost them money. So there's a lot of numbers that have been changed maybe to make these thresholds higher than they should be, so that if it fails, that the manufacturer isn't paying for it. That's ultimately the point. How many people have seen that message that comes up on your screen that says, your drive is failing, imminent failure, please replace my drive? Right? How many people have had a drive? So like 5 of you. How many people have had a drive fail? Wow. That tells you a lot right there. But when S.M.A.R.T works, normally that means something really good to you. Think about this. You have a head. Is the head good? If the head read data from any place on the drive, you have at least one head that was good for the system area. You may have multiple heads, and maybe a head is bad. But one head for the system area had to go and read data from the system area to read the S.M.A.R.T table to report it to you, which means I've at least got one good head, right? Everybody good with this so far? There's a few exceptions, but ultimately that's what we're talking about is we got a system area and a head read data, which means I probably have a good head, which means I might be able to read other data, even if I have another bad head that might not be able to read some data. And I'll explain all that stuff to you in a minute. But ultimately, my whole point is now I know to stop, because also what happened if the head read data from S.M.A.R.T and returned it to me, what else must probably be good? What? The controller, the board, the controller, and your firmware is probably at least running, right? You've probably at least made it through that part. So you already know right away, if I'm able to read some S.M.A.R.T data, I may have made it further than, it doesn't matter if I'm reading user data, I may have actually been able to tell that the drive initialized correctly and it made it through this post routine, because it will be one of the later things that actually happens. There are a few exceptions. Almost all of these exceptions have basically happened in the last year and a half. So I'm going to talk about these really quick before we go to the diagnostics component. First one, has everybody heard of Seagate 7211's firmware problem? Right? So there's at least 2, maybe 3 firmware problems that exist on these Seagate drives. We can fix at least 2 of them now. And when I say fix, we can't always make them work exactly the same way they were supposed to work, but we can make them work well enough to read the data from them, and then you throw the drive away. Right? You guys good with that so far? Because the data is important, the drive is cheap, or should be. So basically, there's a firmware bug, and it can be fixed. And a lot of you probably know. Anybody ever had to send a drive to a data recovery company to fix this firmware problem? No, besides you. No, nobody knows, because you probably just don't even know. You probably just had, a Seagate drive died, I mailed it off. And so they could charge you thousands of dollars to fix this firmware problem that there is a patch for. You can fix it for $25. Okay? You can fix this problem for $25. Here's what you do. There's a cable. I even gave you the link to the cable. Go to the website, download my slides, click on the link, go to the cable. $25. There's your $25. Then you can go, and you basically have to get the firmware downloads. I have a web page that also has the firmware stuff up for the Seagate stuff. You are going to take this cable, and you're going to cut it. And you're going to connect it to a serial port. Now, on the back of all Seagate drives have a serial port that works just like a modem. You hook up these 2 wires, you start up terminal, and you talk to the drive through a serial port. It does not even need to be, and I don't mean the SATA interface, I mean there is a serial port. I mean a courier modem blinks at you, you unplug the cable, you plug it into, that's what I mean, literally. So I'll show you that in a second. But ultimately, these pins over here that most people didn't even know that would normally set your speed, which are usually set, by the way, to a default of limit my transfer rate to 1.5 gigabit. Not that you have a controller that can do this anyway, so it doesn't really matter, or a drive that spins that does this, unless you have solid state. But most of you didn't even know you probably had a jumper there that set that to 3 gigabit versus 1.5 gigabit. Anyway, that's what that jumper is. You hook up these 2 wires, the orange wire from that list and the yellow wire, and you plug this into a terminal. And you will be able to tell almost all diagnostics problems with Seagates. Whether you understand them or not is a different world. But you can see on a terminal screen what is wrong. The Seagate drive will actually tell you, I'm a Seagate drive, here's my firmware, here's my model number, here's my stuff, and it'll tell you that right there. And then if there's a repeating error, it will tell you what the error is. And there also is like a static. Now, when I tell you that there is a terminal and you can hook up a wire to it and you can see what's inside your Seagate drive, this is not a typewriter, okay? Do not just start, I can write Word documents in this, okay? Because your drive will do things based on individual characters, so don't just be like hitting random keys. I can tell you hit something like a period and it will give you a status line that it will actually talk to the drive, it'll say what is your status, and it'll give you back a health line and it'll tell you everything it needs to know in one health line. Now you still have to interpret what that means. So, but all Seagate drives of all IDE, SATA, or 3.5, 2.5, they all have a serial port. This is going to be a small video on what this particular bug called the pending bug is. This is not one that you can fix. Okay? If you see a screen that looks like this, when you physically hook up a cable and you're looking at your diagnostics, it's cool just to see it if you're just even doing diagnostics, but you cannot fix this problem. So if you see this, you know right away this is not something you can do. It will just keep looping through this process. Now what this type of bug is about 20 seconds after a Seagate drive is initialized, it will start going through doing checks to see what bad sectors are and doing wear leveling, shuffling bytes around on your disk. Yeah?
Just off topic, but can that serial cable read and write data to the disk?
You can really send commands to the system area or to a command processor, and you could like format, reinitialize disk and stuff, but that's not its purpose. So you have to know quite a bit of commands. There's like 75 pages of commands. So there's a lot of things that you can control, but it's primarily for firmware and